Hello class. Today we're going to talk about similarity. So the standard that we're looking at, we're going all the way back into a 7th grade standard, which is called proportionality. And what we're really looking at is this A part down here, which says we're going to generalize the critical attributes of similarity. So by the end of this lesson, you'll know the 4 conditions that figures need to meet in order for them to be similar. So in this lesson, we're going to learn to use ratios to determine if 2 figures are similar. And we're going to have some vocabulary that we're going to look at today. We're going to look at similar, corresponding sides, and corresponding angles. So let's start off by talking about similar. Octahedral fluorite is a crystal found in nature. It grows in the shape of an octahedron, which is a solid figure with 8 triangular faces. The triangles in different sized fluorite crystals are similar figures. Similar figures have the same shape, but not necessarily the same size. So the first 2 characteristics of similar figures are they will be the same shape, but they won't be the same size, but not necessarily the same size. So in order for 2 figures to be similar, they must look the same, but they are going to be typically different sizes. One will be smaller than the other. So let's look at the next 2 definitions: corresponding sides and corresponding angles. Matching sides of 2 or more polygons are called corresponding sides, and matching angles are called corresponding angles. So when we look at this figure down here, we've got this line segment AB right here. Okay? Well, that corresponds to line segment DE, because correspond means the same place as. The same place as. So, and then we just look at it in 2 different figures. So line segment AB is in the same place as line segment DE, and those are called corresponding sides. Now, corresponding angles are the angles in the same angle on the 2 different figures. So angle B is 82 degrees. Well, its corresponding angle is angle E because it's in the same place as angle B just on this figure. And you'll notice that the corresponding angles have the same measure because the next 2 conditions are very important when we're dealing with corresponding sides and angles. We'll talk about that in just a moment. When naming similar figures, we list the letters of the corresponding vertices in the same order. In the previous table, triangle ABC and triangle DEF are similar, and that's what this little squiggly line is, or the squiggle here. It stands for similar. So when we name this, it says triangle ABC is similar to DEF. So A has to be in the same place as D, B has to be in the same place as E, and C has to be in the same place as F. So if we go back and look at this, you'll notice that A and D are in the same place, B and E are in the same place, and C and F are in the same place. Right? So that's what it means to have corresponding parts. Right? But when you're naming a figure, it's very important to understand that these letters have to be in a particular order. Right? So if I'm looking for corresponding sides, I can also find them by using the letters here. It says that line segment AB would be in the same place as line segment DE. Right? So when we look back, we find out that that is definitely true. AB and DE are in the same place. Now, what are the other 2 characteristics of similar figures then? Well, the last 2 are 2 of the most important. Okay, so we know that the first one is they've got to be the same shape. The second one is they've got to be different sizes. Well, the last 2 are the measures of their corresponding angles are always going to be equal or congruent. Okay. So when we look back at this figure, the corresponding angles are all the same. 82, 82, 43, 43, 55, 55. Okay. Now the last one and the most important definition is, or characteristic is, the ratios of the lengths of the corresponding sides must be proportional. In other words, if I knew the measure of this side right here, and this side, I can multiply all 3 of these by the same number, and I would get the measures for these sides. Okay, so they must be proportional. So the 4 characteristics are, okay, similar figures must have the same shape, but different size. Corresponding angles are equal, and corresponding sides are proportional. Those are the 4 characteristics. So let's see if we can use that to determine if figures are similar. So here is an example. Okay, it says, identify the corresponding sides in the pair of triangles. Then use the ratios to determine whether the triangles are similar. So we look here, we've got triangle ABC, and we're trying to prove whether or not this triangle is similar to this triangle, which would be DEF. You'll notice that the triangles have been rotated, okay, so or flipped, right? Also in relation to each other. So what we're looking for is, right? Can I take each of these measures of this triangle, triangle ABC, multiply them by one number, the same number, and get triangle DEF, get the measures of that triangle. So if we look at side AB here, okay, what part corresponds to that in the other figure? Well, that's going to be DE. So is there a number that I can multiply 4 by to get 16? Yes. Okay, I can multiply 4 times 4 to get 16. Okay, so now what I need to do is determine, can I figure out if all the others do the same thing? This 7 right here, can I multiply it by 4 to get its corresponding part? Well, the corresponding part of BC is EF. So 7 times 4 gives me 28, so it works. I can also do 10 times 4 to get 40. So what we really can do on this is we can actually set up some ratios. Okay, we could set this up as line segment AB divided by its corresponding part, which is line segment DE. And that should be equal to line segment BC, or the measure of line segment BC, and the measure of line segment EF. Okay? Then I can do the same thing with the last one. Line segment AC is equal to, or is the same thing as DF. Okay? Now, if we were to take each of these and substitute in their values and then simplify the fraction, all the fractions should simplify to the same thing. So AB and DE are 4 over 16, which we know simplifies to 1/4. Okay? That should be equal to BC over EF, which is 7 over 28. And then 7 over 28 also simplifies to 1/4. Okay? And then the last one, AC and DF, AC is 10, DF is 40. That also simplifies to 1/4. So if the ratios are all the same, then we can say that these two figures, triangle ABC and triangle DEF, are similar. And that's how we determine if figures are similar or not. Okay? So let's look at another one real quick. So here's another one. And we can set up the same ratios again. Okay? We can set up this AB, which is 3, over DE, which is 9. Okay? Because those two are our corresponding parts. So this simplifies to 1/3. Now I can do BC and EF, which are those corresponding parts. And those simplify to 1/3 again. Okay? And then the last one is AC, which is 9. And then DF, which is 27. And we find out that those also simplify to 1/3. So if all those fractions are equal, then these two triangles are similar. And we would write it again as triangle ABC is similar to triangle DEF. And that works the same with all the shapes. Okay, we could use a 4-sided figure and do the same exact thing. So if we looked at this one right here, tell whether or not the figures are similar. So we go through our 4 characteristics. Are they the same shape? Yes, they are. Are they different sizes? Yes, they are. Are my angles, my corresponding angles, all congruent? 80, 80, 90, 90, 65, 65, 125, 125. Yes, they are. And then are my sides proportional? That's the one that we got to look at. So we can say that the corresponding angles all have equal measures. What we need to find is, are the side lengths the same? Okay? So let's see if we can do that. So what we can do is we can write out all of our corresponding parts. MN corresponds to QR. NO corresponds to RS. OP corresponds to ST, and MP corresponds to QT. Okay? So we write that up, and we then replace each of these with their corresponding values. Okay? So we replace them with their corresponding values, because this is the question that we're asking. We replace them, we simplify each one to try to determine, are they all the same? They all simplify down to 2/3, so that means that these two shapes, quadrilateral, quadrilateral MNOP is similar to quadrilateral QRST. Okay, so they are similar. We can do the same thing with another one. Okay, so this one's the same thing. We're looking at those same pieces. Okay, do they all match up? So are they the same shape? Yes. Are they different sizes? Yes. Are my corresponding angles congruent? Yes. Okay. Are my corresponding sides proportional? That's what we have to figure out. So you write out the ratios. Okay. Same kind of thing, same letter combinations basically as what we had in the previous one. We just changed the numbers up. Okay, and then you set up your proportions. Okay, so we set up our ratios. We write our numbers in. We simplify each one of those, and we find out that they each simplify down to 1/4. So, are they similar? Yes, they are. They are similar. So, last two questions just to kind of see if you understand what's going on. Okay, tell whether or not these figures are similar. So we go through our checklist. Okay, do they look alike? Yes. Okay, are they different size? Yes. Are my corresponding angles congruent? 59, 59, 35, 35, 86, 86. Yes, they are. And then we look at our corresponding parts. Corresponding part is NO and QR. So we have 4/8. Okay, and then we've got 6/12. Then we've got 7/14. Do all of those simplify to the same thing? They all simplify down to 1/2. So these two figures are similar. Okay, so get another one. So far we've looked at all the ones that all the ones that we have looked at have been similar. What about this one? Okay, so do they look alike? Yes. Okay, are they different sizes? Yes. Do they have corresponding angles that are congruent? Well, here's a 119. I look down here. I look at all of them, and none of them have a 119. So that means my corresponding angles are not congruent. So this one is not similar. If they don't meet one condition out of the 4, then they're automatically not similar. So again, what are those 4 characteristics? They must be the same shape, different sizes, corresponding angles must be congruent, and corresponding sides must be proportional.